Hey everyone, and welcome. So, you're diving into Kotlin? Awesome. You are in exactly the right spot. Today, we're going to tackle the most fundamental thing in all of programming, and that's variables. Let's jump right in. Have you ever really thought about it? You're playing a game, and it somehow remembers your high score. Or you open an app, and it says, hey, welcome back. How does it do that? Well, it's not magic, I promise. The app needs a place to hold on to that information. And that right there is the whole reason variables exist. And the solution, it's actually is super simple. Just picture a little box, like a container, that lives inside your program's memory. All you do is slap a label on it, give it a name, and then you pop some information inside. Seriously, that's it. That's the whole big idea in a nutshell.
Okay, so let's dig into the details. In Kotlin, what do these containers actually look like? And what kind of choices do we get when we're making them?
Right off the bat, when you go to make one of these containers, Kotlin makes you pick. You've got two main options, two totally different kinds of boxes. And the one you choose really matters for what you can do with that data down the line.
And that brings us to maybe the first big rule you got to learn in Kotlin, the difference between var and val. Getting this down is absolutely crucial, but don't worry, it's actually way easier than it sounds.
Okay, so check this out. On one hand, you've got var. Think variable, as in it can vary. It's changeable. The data you put inside of our box can be updated later. A game score is the perfect example, right? It's got to go up, maybe down. That's a var. Then, on the other hand, you have val. Think value. This one is the total opposite. It's unchangeable. Once you set it, it's permanent. It's locked in. A date of birth is a great way to think about it. That never changes. So, simple rule, var for things that change, val for things that stay the same. Got it?
Oh, and hey, a quick little pro tip here. If any of you are coming over from Java, you'll feel right at home. The val keyword in Kotlin, it's pretty much the exact same idea as using final in Java. Same job, different name.
Okay, cool. So we know what they are and why we need them. The next big question is, how do we actually make one? What's the code look like?
You know, it's way simpler than you might think. There's basically a blueprint, like a recipe, that you can follow every single time you need to create a variable. Let's just break it down step by step. And here it is, the whole shebang broken down into 4 simple parts. First up, the keyword. This is where you make that big choice, var or val, changeable or not. Number 2, the name. You got to give your little container a unique name. And yeah, we usually write it in what's called camel case, like you see there with my name. Part 3 is the type. This is you telling Kotlin what kind of stuff is allowed in this box. And last but not least, number 4, the value. This is the actual info you're storing inside. So when you look at that full line, var my name string equals Suresh, you can see how it follows that recipe perfectly. And hey, can I tell you some good news? Something that'll make your life a little easier? Check this out. In Kotlin, you don't need those pesky semicolons at the end of your lines. Nope. The language is smart enough to know where a line ends. It's a small thing, for sure, but man, it makes the code look so much cleaner. All right, let's circle back to that third part of our blueprint for a second, the type. Why is that even a thing? Why do we have to bother telling the variable what kind of data it's holding? Okay, I have to share this because I just love this analogy. Think of the data type as the variable's tribe. It has to declare which group it belongs to. Is it in the text tribe or the number tribe? This is how Kotlin knows what's possible with that data. It makes sense, right? You can't ask it to do math on someone's name. That's why these types are so important. So to get started, let's just focus on the 2 big tribes you're going to meet all the time. First, there's string. This is for any kind of text, a word, a sentence, you name it. If it's in double quotes, it's a string. And then you have int, which is just short for integer. That's your go-to for whole numbers. 10, 90, even -5. All of those are ints. So when you write your code out like this, you're being what we call explicit. You're basically spelling everything out for Kotlin. You're saying, hey Kotlin, I'm making a val named score. Just so you know, it must hold an int. And by the way, its value is 90. You're leaving nothing to chance. But this is where Kotlin gets really cool. It's a smart, modern language. A lot of the time, it can just look at the value you give it and guess the type all on its own. It's this awesome feature called type inference. So what does that look like? You can just write this
That's it. When Kotlin sees equals 90, it just knows. It says to itself, okay, 90, that's a whole number. This must be an int. You don't have to spell it out. This makes your code so much shorter and cleaner to read. Honestly, this is how you'll see it done most of the time.
All right, we've done the hard work. We know how to create variables, how to give them types. Now for the fun part, the whole reason we do this. What's the point of just storing information? The point is to actually use it. So let's see how that works. So let's imagine we make two simple variables. We'll use that slick type inference we just learned about. We'll make a val called name and set it to Rana. And we'll make another val called marks and set it to 90. Easy enough. And now for a little bit of magic. We can mix plain old text with the data from our variables. We can write out a sentence, and anytime we want to drop in the value from one of our containers, we just put a $sign right in front of its name. See that? It's called a string template. Kotlin sees that $sign name and $sign marks and automatically swaps them out with Rana and 90. And boom, there's our output. The program grabs our template, pulls the info from our variables, and spits out this perfect, complete sentence. That is what variables are all about, storing information so you can use it and reuse it whenever you want. So, there you have it. That's the foundation of everything. A player's name, a high score, what's in your online shopping cart, it all comes down to a variable. You now have the power to make your programs actually remember stuff. So the only question now is, what are you going to build with that power?